Good morning, good afternoon, and welcome to Smartlogic's webinar, Supercharge Machine Learning Algorithms with Semantic Technologies. My name is Ann Kelly, and I work in marketing communications here at Smartlogic. And our speakers today are Steve Ingram, who is part of our solution architecture leadership team here at Smartlogic, and Frederick Bednar, who's a data science consultant with our partner EBCONT. A few housekeeping items before we get started. This webinar is in broadcast mode, and so all of you are muted. If you have questions, and we encourage questions, please put them in the GoToWebinar panel that you should see on the right-hand side of your screen. We have about 40 to 45 minutes worth of content today, and then we'll open it up for Q&A and answer as many questions as we can in the remaining time. And finally, this broadcast is being recorded, and replay information will be sent to all registrants one day following the broadcast. And I'm going to turn it over to Steve, and he'll kick off with the agenda.
Thank you, Anne. In the next 45 minutes, Frederick and I will be introducing our respective companies, discussing the challenges represented by machine learning, and show you how Semantics can help reduce those challenges. And we should have 10 to 15 minutes at the end for any questions. So let's start by introducing Smartlogic. So we've been around since 2006. We're a privately owned software company. And our mission from the start has been making sense of text. As our founder, Jeremy Bentley, puts it, 80% of the world's data is in documents, but you can't ask a PDF a question. Our first customer in Europe required us to process the world's news in near real time. And our first customer in the US needed us to enrich 50 years worth of material on spaceflight and related projects. Interestingly, that was a referral from a well-known search company who said, no, sorry, we can't help you with that, but we do know a company that can. And so we opened our opened our US office in 2010. In 2015, we completely redeveloped our product, which is called Semaphore, to embrace semantics and open standards such as SCOS, OWL, RDF. And now we have approximately 300 projects worldwide using Semaphore. These projects are typically in Fortune 2000 or world-leading organizations, generally ones that operate in highly regulated environments, but any company that's making use of unstructured content. And we've been recognized as a leader in the Gartner Magic Quadrant for metadata management solutions over the last 4 years. Our tagline is revealing smarter decisions, and that's all about processing data in context to reveal insight. Our platform is horizontal and applicable to many industries. As I said, any that need to manage unstructured content or any that need to deal with highly regulated environments. All of our customers are using the same software to solve multiple business problems. The only thing that changes is the knowledge models that they've configured and are managing within Semaphore. And as a horizontal application, we rely on our partners such as EBCONT to provide industry experience to align our offering with business solutions. So what is Semaphore itself? Well, Semaphore does 3 things. It's about the enrichment of information assets, the extraction of facts, entities, relationships for better analytics, and the harmonization of all these information sources for key business insight. And we do that with three main components. There's the building and management of semantic models, knowledge models, taxonomies, ontologies, control vocabularies, data catalogs. These all define your domain, and we refer to them collectively as knowledge models. There is the use of those models to enrich and harmonize textual content using the models in combination with natural language processing techniques. And there's the use of those models to enable discovery, to enable findability, and to assist collaboration, and basically apply deeper analytics, providing semantics to your business processes. But importantly, Semaphore does this at scale, whether that's handling millions of concepts in knowledge models, processing 1 million documents per day, supporting a user community numbering over 120,000 users. Semaphore is designed to do these at enterprise scale. Now, I've mentioned semantics a couple of times, so it's probably worth just describing what do we mean by semantics. And this is the branch of linguistics that deals with meaning. So in computing terms, we're concerned with what data means rather than how it is represented. Or to put another way, semantics is all concerned with things, not strings. So elements in a semantic model are authoritative, unambiguous, and self-describing. And by definition, a semantic model has to be schemaless, as it will inevitably contain elements of different type. Now, here's an example of how a deeper understanding can turn raw text into actionable data. This is what's referred to in the pharmaceutical industry as an adverse event report. As the name suggests, this is an adverse event reported by a patient undergoing some form of clinical trial. So on the left, we have typically how these reports are submitted. They are just raw text, and it's written in a narrative form using natural language, which is great for capturing the information from the patient, but is not so good for when you actually want to do something with it. And so what we do with Semaphore is apply the knowledge models. We apply our natural language processing engine to this. And actually what we return on the right is high fidelity, high veracity data. So we're going from, we can report the patient age, patient ethnicity, patient sex, but more importantly, we can actually say what drugs the patient was experiencing, was taking, and for what was the dosage. And we can return the recognized scientific name rather than what the patient would be referring to them as. And we can report the actual adverse event itself and the date. And we can lift this information from the text. So we're going from raw text to high fidelity, high veracity data, which is suitable for downstream processing. And this in itself is a classic illustration of what Semaphore brings to the field of analytics. So there's a lot of different areas where we can help, but fundamentally we're providing two main capabilities. The first is where we are painting unstructured data with a rich layer of relevant metadata. And we're so basically placing unstructured data into a world where it's using the definitions, it's using your frames of reference, and it's using the definitions that are in a structured manner, and these are then can be used by analytical processes, business intelligence, and the rest of the infrastructure for a kind of reporting. And secondly, we're automating stare and compare activities. These are activities which would normally require a human analyst to review reports and fill in database records or spreadsheets. So for example, if you're a financial institution, you have a know your customer commitment, and so you'll be processing letters of reference, tax information to determine if you want to take that customer is safe to take on. And that's typically done by an analyst staring through loads of reading documents and filling in values in a spreadsheet. And on a wider level, if you're in for example, the reinsurance market, you could be having policies, with 7, 8, 9-figure implications or risks, and these are expressed in English. They're deliberately expressed in potentially obscure manners to try and get the maximum benefit from the policy. And these, if you actually wanted to base your decisions on what your exposure would be to various policy events at a point in time or in future, you would physically have to read through 7 or 8 passes of a spreadsheet that's been maintained by a human reading multiple contracts. So these mandrolic techniques are inefficient, they're error prone. And by using semantic techniques, by applying the understanding of what's being read, you can actually automate these processes to provide much cleaner and much better described data to be fed into analytics or machine learning techniques. So with that, I'd like to hand over to Frederick, and who will introduce EBCONT and talk more about the challenges of machine learning techniques.
Well, thanks a lot for the introduction and for having me here. Can you see the screen? Is the presentation still active?
Yes, we can.
Okay. Thank you. Well, I really appreciate this opportunity to share some of my thoughts, my insights, and best practices about combining machine learning and semantics in this webinar. Just a few words as a starting point to get to know us, who we are, as I'm not sure how many of you are really familiar with EBCONT. In short, we are a privately owned full-service IT provider with 20 years of experience on the market. We are located in the so-called DACH region that consists of Germany, Austria, and Switzerland, and our headquarters are in Vienna. But we do operate globally with customers from different industries in Europe, the US, and South Africa. Just a couple of them are mentioned on this slide. Our services can be grouped in 3 areas. Implement the business, where we create custom B2B, B2C, or line of business apps for desktop and mobile for our customers. Transform the business, where we create data platform and data-driven business apps to support digitalization. And run the business, where we operate solutions for our customers and help them shift to the cloud or containerization. So our holistic approach is not serving as an IT consulting or a software development company only, but to provide the whole IT lifecycle of a project. This is really essential part in our work, and of course appreciated by our customers, as they can get everything one stop. One thing to add to the transforming step, we consider the field of a data-driven process. In our delivery model, our approach is usually structured in a short discovery phase of thoroughly analyzing the provided data and the potential of new data or external sources, then setting up the necessary infrastructure and solving a reference use case, by not picking the easiest, but in fact the strongest pain point. So this is where we have made great experience with working with a broad variety of technologies and together in alliances with strong global partnerships in different domains, and Smartlogic is one of them. So I hope this can give you a brief overview of how about what we are doing. And with that, and without any further hesitation, let's jump right into the topic. I will start with a couple of short definitions. First of all, when we talk about machine learning, we talk statistics. All of the models and algorithms rely on statistical methods, which are designed to find empirical patterns in data. The better the design of your model and the better both the quantity and the quality of your sample data, the better the behavior of possible predictions will be. So as a matter of fact, most of the problems are about optimization. For us, it is important to note that machine learning creates business-ready solutions. So our models should operationalize and be able to improve continuously. This actually plays a vital role for this field from a practical point of view. In this context, and as a general definition, deep learning, as you may know, is to be considered as a subset of machine learning, mainly focusing on neural networks. On the other hand, natural language processing, or in short NLP, just shows the ability for computers to understand human language in any kind of format, mostly text or speech. I have to emphasize that not every NLP task is related to machine learning, though. There are heuristics or linguistic rule-based approaches without any claim to predict something. So those scenarios would not need machine learning from an evolving point of view. However, the main spectrum of text-based use cases nowadays will be found in the middle section. And named entity recognition is a sub-item, which means the gathering, the extraction, and classification of information in unstructured text. For today's session, and for a better understanding, we thought of just giving you a glimpse of a well-defined example. There are tons of possibilities, but for the sake of a limited time, we chose this one. Imagine that we set our target to extract and analyze data from an existing text, respectively, out of several documents. We would like to classify our source, model some topics, and we would like to use the gathered information to create predictions for upcoming new files. This is a very common example, and of course, there are different approaches, both in the machine learning, or nowadays mostly deep learning and NLP section. However, in practice and when using enterprise data, we do face some challenges. Text-based use cases are a very challenging and complex field in all of the variations human languages could provide. And you probably won't have only one single source of truth, as enterprise data comes from different sources, whether you don't, when it comes from different sources, this is structured only in single cases. And even then, you really have to check out that structured data first, whether you don't receive any unclear or even misleading information. Then you have all the pre-processing steps to make data usable for your model, both in structure and content. The information itself is often static, respectively heavily dependent on the input data. So we do not have any time-based or dynamic information covered at all. Highlighting linguistic tasks, it is definitely a matter of how the natural language understanding needs to be tweaked. There are predefined core models on a very high level of general language, and they will be fine if your use case relates to everyday use of general language, but customizing onto your domain is a crucial part from a practical point of view. So texts in legal or finance or healthcare, as I mentioned previously, for instance, they use a lot of specific and custom words, and you have to make sure to detect them correctly. So overall, it's a matter of whether you could confine your domain as clearly as possible to use correct sample data, which reflects your target in a fitting manner. And last but not least, there will be differences in quality output between languages you have to consider. One general example, just to show you on the right side of this slide, my name Frederick would generally be recognized and defined with the entity of a person. But there could be cases where Frederick shall be considered as, for example, a location. There are plenty of towns in the US that are named Frederick as well. So just checking the isolated sentence won't help. You will need the context. In most cases, this should be covered within one text document, like in this example with Frederick in Colorado. But sometimes don't, and you need more data from different sources, because here it isn't 100%, you're not 100% sure, not 100% clear. From different sources, or you need some filtering, maybe some predefinition of what is the topic of the document. So the shown example here might be a very simple one or somehow created, but it clearly shows that ambiguous cases appear more often than you think, and a decision might be hard to be reached. So to sum it up, when it comes to linguistic understanding, there is a high probability that a classic NER approach will lack of quality. So let's have a look at the typical workflow of an entity recognition process. First of all, you will need fitting data, of course, which is being loaded into the system. After that, we do have to define what parts of the text are relevant to us and to be used as entities, and what should be the meaning of that entity. So persons, locations, organizations are very general. So actually there's already some customization to do in most of the cases. Then of course, the annotation of your training data to create some gold standard of how the text data should be. This is something besides from all the data cleaning stuff in advance, which is called the hard and dirty manual work. And many data scientists really do not like that. Why? Because it takes a lot of time. It might be boring, it might be repetitive, and still you have to be very precise all the time and clear. The more manual workload you have, the more error prone the results might be. Sometimes it's almost even impossible to make a single decision on annotation as shown before. So in the worst case, you might have the frustrating overwhelming input being done combined with an output not being sufficient. There are methods, though, that could help to minimize the labeling costs, such as an own creation of a support vector machine or hidden Markov model. But implementing them in a correct and practical manner actually also takes a lot of time. And you will see this progress not before the next step, the training step of your custom model, where you check of how well the annotations are detected and predicted. That has to be done before the run and the execution of both the core and custom models. So in order to minimize both workload and error proneness, it would be great to have some predefined information. And this is where semantics come in place. Let's have a look at an example of our annotated data, both usable for training and for output, or even in some process of maybe some reinforcement learning. When thinking of what does the model learn, actually, we will see that first of all, and as a baseline, you will get part of speech tags that show the word type, word categories, hence, of course, the named entities, which means the names itself will be trained and get detected by the system. But generally, models, of course, will also learn patterns within the text as well as within the context of sentences. This is done with the help of the language models I mentioned before, as They're being used to train your CRF or BERT or any transformer algorithm whatsoever. So in this example, we see some persons, we see some authorities, but also some judges from a legal text. But of course, one thing that really interests us is what could the model learn, respectively, what won't the model learn? And yes, experience, and this is something we could really observe in our projects conducted. Experience shows that if you stick to NER only topic modeling, you'd probably reach some limits every now and then. First of all, your training data needs to be variable enough, as stated before, to also consider different meanings of the same text pattern. Think about any kind of alternative labels, such as synonyms, two different words for the same meaning, or homonyms, same word with two different meanings, or variants in spelling. Also something you definitely should not underestimate. But what will be missing completely is any kind of relationship between the named entities. They won't be shown or learned, not even in the context of this document, not to mention different documents overall. Of course, there are core reference models in NLP tools, but especially maintaining them is also a challenge, another challenge. Another thing is also a problem that these patterns do not consider position in text if you do not train that separately. So that might lead to either under or overfitting. So one entity could usually appear anywhere if not trained correctly. And this could lead to strange mismatches that you would not even think about as a reader, but an isolated model won't go out of the box. Just as an additional point, any kind of multi-language is also very hard to maintain, because if you use models trained in different languages, you really have to take care that you don't totally mix up your output. So overall, relationships will be both hard to detect and to maintain, unless you have any structured data ready, which is rarely the case. But to exceed the given limits and bring your unstructured text in order, one proper solution will be working with taxonomies and tautologies. And this is something we'd like to show you today. So here we see our target once again. And with the classic NER only approach, we now have solved just the first part, if at all. We still need to classify the topic of the whole text itself, respectively a document. So you would need to train an all model just for classification, where you have a limited set of topics, generally to be defined manually. And another remaining step is checking how we could use this information in further steps. So let's have a look on that. And therefore we, respectively, Steve has provided a short demo of enriching data within legal decisions. We took the topic of legal texts by intent, as they are a rather complex domain, hard to understand, and use a lot of terms you won't find in the usual Twitter feed. So general approaches won't help at all, and potentially a high level of customization would be necessary. We used for this demo data from the European Court of Human Rights. Their decisions are case law. There are over 64,000 judgments. They are publicly available over via the so-called HUDOC platform. And there are structured case details available too, but not compulsory on the case text itself. So no direct contradiction. And our goal is to get a quick but robust overview of topics and facts included or excluded in distinct case files, such as keywords. And with that, I'd like to hand over to Steve for a demo.
Thank you, Frederick. Let me just get my screen shared. So, yep, and let me move on to the next slide. So, as Frederick said, we have the case law published by the ECHR. It's in various formats, and in this case, quite rarely, the document files themselves are tagged with the complainant, the plaintiff, and the defendant country. But there's no other metadata that can really help you. And if you, for example, if you wanted to, if you just wanted to identify what were judgments versus what were, actual decisions, if you wanted to identify the points of law that were covered off in each case, If you wanted to understand what was, what each case was about, if you wanted to find out actually what the decision was for further processing, or if you wanted to review the panel, you would need to read through a lot of noise to retrieve the information that you actually want to perform. You actually need if you want to perform deeper analysis of the data. And as Frederick said, this is quite a complicated domain. So this is not general purpose definition. So general language processing may not help you particularly in this process. So these nuggets of information will be buried in quite a lot of procedural noise, and there's no point burning carbon processing things So this is a very good case where some domain knowledge encapsulated in one or more knowledge models can actually assist with the process of actually understanding this content and revealing the nuggets of information. So what we're going to demonstrate is the process of Semaphore fact extraction, surfacing additional metadata which has been lifted directly from the text. The key thing about Semaphore fact extraction is that this process is done without code. So instead, we model how the information is kept, how the information is represented within these documents and we define patterns using linguistic constructs such as part of speech. We can use entity recognition. We can use static text is also useful, and we can use values from one or more knowledge models to identify the context where information is held, and then surface that as actionable metadata. And this is a declarative process. So it's not it's not writing code. You just define the patterns you're looking for, define how they relate to each other, define how you want them to be represented in the metadata payload to the downstream systems in a knowledge model, and Semaphore will perform the rest of the processing. And these definitions themselves can take advantage of any other sets of definitions you have you're maintaining. So you could have a legal taxonomy, you could have a general purpose subject taxonomy, you could have industry specific taxonomies. And these definitions, these kind of known knowns, will give you a very great head start for actually and let you focus on trying to understand how these things relate together. There's a much better use of resources indeed around machine learning. And so what we end up with is this kind of display where you have on this display will be the document itself on the left-hand side. On the right-hand side will be the metadata that's returned. And in an operational system, this will be happening behind the scenes. So this is not an interactive. I'm showing you an interactive process to explain how it works. But in reality, we'd be embedded in a data processing pipeline or a content management system or a search engine, providing this enrichment behind the scenes. So let me stop showing slides for now, and now go to my browser. So this is Semaphore. This is running on my local laptop, and this indeed is this is what we call the Semaphore Studio. So these are the three components. I have the modeling component, which defines not only the knowledge models that I'm using for processing, but also the domain models that can also contribute to that process. We have the classification tool here. So this is what I'll be using to show you how we process the documents. And on the right-hand side, we have the semantic integration component, which is all about using the definitions and using the models for findability and discoverability. So I'm going to run, this is the document analyzer. Actually, to be honest, I already have one running. And so what this tool does is this is a window onto the enrichment process. So I'm going to collect one of my documents. Let's start with a judgment. So I'll start with this one. I'm dropping it into the what we call the document analyzer, and then I'll submit it through to enrichment against what we call the classification server. And so what comes back will be on the left-hand side will be the text of the document. So it's picked up a Word document, retrieved the text, performed the part of speech analysis, compared it to the taxonomies, compared it to our fact extraction model, and on the right-hand side, this is the metadata that we're returning. And metadata can be just sort of flat lists, so flat type. So we have, for example, we've identified it as a content type, as a legal notice, and we said it's an ECHR judgment. And the reason why we said it's an ECHR judgment is because it fits the fingerprint of a judgment document. And actually that fingerprint is dictated by the fact that's extracted. So you could fingerprint just on whether or not the document says judgment, but you could also fingerprint based on the sort of information that we're retrieving from a document. So you don't need, so we're not hidebound by how information is necessarily appearing on the page. It doesn't need to be certain words at the top, other words in the middle. We can actually identify what is the document talking about, what are the key facts, and actually then use that to judge what the document is about. So we have here, this is the applicant, the application reference number, the authority is the 4th section of the ECHR, and it's against the Netherlands. Now, some of that was in the title, but we didn't have the case number. And we didn't know, for example, that this is actually an applicant. So this isn't identified as a person, whereas it's not an organization, it's not a group of people, this is actually a person. As I said, it's identified as a judgment. So we have here the judgment summary. So what we've done here is classified using a general purpose taxonomy, the text of the summary of the judgment. Now, we could have fired this classification against the entire document, but that is losing the context. But because we know we fingerprinted this document as a judgment, we know where the summary sits. And so we can classify that specifically and say, this is what this case is about. So this case is about human rights. Well, that would figure from its ECHR. But specifically, it's about video conferencing. And I would never have guessed that from the title. And it's about hearings at the court of law. So not only can we get a quick summary of metadata for processing this document, but we can actually also prove every decision, every piece of metadata, any action of enrichment provided by Semaphore is immediately traceable, which is very particularly relevant if you're working in a controlled environment. So that's the summary, and then if we actually look at the panel itself, we've picked up the panel president is Jonko Grozev, and then we have the deputy section registrar. A couple of things to notice here. So we've identified these names as actually current members of the bench. And indeed, Jonko Grozev is current president of ECHR. But we found a name here. So we've used entity recognition to say, oh, we've got a name here we've not recognized before. What is the context of that name? And actually that matches the title, deputy section registrar. But actually, if you notice, actually it doesn't. This is spelt wrong. Simple spelling correction, we can apply that to our definition of our roles. And so we're able to say that we have a name we didn't know before, but this person actually is deputy section registrar. And if we were doing, we can process this in two ways. So we know the role this person is performing on this case, but we could also use that information to enrich our knowledge model. So it's a potential process of enrichment, not only the data we're processing, but also the process of analyzing that data. So that's a judgment. Let's open another document. Let's look at a decision. So let me pick, where's Pago? There he is. And just for completeness, this is the, oh, hang on, it's coming back. This is actually the PDF. So again, we have here, we've processed the document, we've fingerprinted it. Now we're saying actually it is it's a legal notice. That's fine, but this is a decision. We're able to retrieve the same case information. Again, this is an applicant. We've got the case reference number, the authority, who it's against. We have the view of the panel. And again, we found another name we weren't recognized before. So we have the acting deputy secretary registrar is not a name we knew before, but we have the panel and the president as before. And again, this is a decision. So we want to know what this case is about. So let me expand the decision. And then here's where it's maintained in the document. So it's maintained in a completely different place. Then we have, again, we pass that against our taxonomy. We can see what the concerns are about. Maladministration and children. Then the other thing is obviously that's what it's about, but what was the actual outcome? And again, we know in the text where the outcome is coded, so we can actually say it's a unanimous decision and this was the decision that was taken. So this can be just lifted. And so if you wanted to know what was the outcome of the case, you don't have to process the entire document, because we found that using our fact extraction framework and surface that information, and that could be passed down as additional metadata, or just you could just use that for applying deeper analytics and techniques. So how do we go around doing that? So what we have is inside our Semaphore knowledge model management, we have five knowledge models that are contributing to that process. The primary is this one in orange. This is what we call this is the master primary model. This is actually doing the fact extraction. It's using this model here, which is fact extraction definitions. So these are all, this is kind of a framework. So these are some primitives and some defined sequences. These are the building blocks that our fact extraction model is using. We have two subjective taxonomies. We have a legal taxonomy from our partner WAND. So these are standard legal definitions. And we also have a subject taxonomy. This is a general purpose taxonomy that we actually distribute with the product. And then lastly, we have this model here, and these are definitions used by our fact extraction framework. And this is where we can maintain reference data that's actually used by our extraction process. So things like the ECR, our bench, and the names and locations, they can be maintained by a completely separate team. So you don't need to be trained in the fact extraction processes to maintain this. Very easily maintained by just anybody who knows how to use the tool. So let's actually look at the fact extraction model for completeness. I have it open here. So on the left-hand side, we have what we call concept schemes. These are just different sets of information. We have our subjects taxonomy linked in. So these are all sort of general purpose definitions. We have our legal taxonomy linked in if I need to use those definitions as well. And then we have up here the facts that are being extracted. And these are, it's a declarative process. So if we want to look at the ECHR decision, this is how we define the fingerprint. And this is the sequence that we define. So if we actually look at the sequence itself, we're just saying any document that matches this pattern, which is a combination of extracted facts and so it's what we call a near ordered across sentences in documents. So we're looking for a pattern of consecutive sentences, and they need to fit these patterns. And if they patterns are met, then that fact is returned in the structure that you saw before. Then the other model that we use is this definitions model. This is effectively, if you like, the reference data that's used by our processing. And this is where we maintain some various pieces of reference information. So we have in here, we have the, for example, the current bench of the ECHR. It's publicly available information. So we know, for example, the judges and where what their nationality is. And that nicely feeds into the geographical information. So you can start to link all these information sources together, and you can start to reuse this knowledge, not only in doing the fact extraction, but also assisting in discoverability. So we have all the countries that are mentioned in Europe, and we can see who are the judges for these countries. And this is just maintained in a very, very flexible, very customizable manner. And then lots of other definitions. So we have things like standard definitions of titles, standard definitions of roles, and these can all be maintained completely separately from the actual fact extraction framework. And the real power of doing things this way is if we were to look at the bench. So this is the current bench. If one of these judges was actually to retire, I don't need to retrain my model. All I need to do is just move the judge into the retired column, and then the next time that judge's name is processed, it will not be shown as a current bench member, but it'll show as a previous member. So I don't need to retrain the document. I don't need to retrain to say these names are judges, these names aren't. I can just maintain it just with a couple of mouse clicks. And that really is the power of combining, using semantics for the kind of the heavy lifting, and then letting the machine learning provide do the clever stuff, if you will, over the top. So hopefully that's given you a flavour for what you can do with what semantics can provide in this kind of space. And with that, I'd like to pass back to Frederick. I think you're on mute.
Thank you. So thanks for the great demo and overview. So when going back to our target, how has the enrichment with semantics have helped us? The enriched data will help not only to learn isolated patterns, but easier, better context and references of documents. We are able to get these topics as categories for the document itself without the need of an extra labeling. We will be able to additionally use these topics for categorizing documents. And this classification later will help us to fine-tune our models. For instance, we could use different smaller but focused models that will fulfill specifications of, let's say, civil law with respective of a specific country, better than just trying to work with one global model. Finally, the shown example is just one of the possibilities and possible use cases that bring semantics and machine learning together. There are many more, but as our time is limited today, we just wanted to give you a glimpse of this helpful solution in our ML pipeline. With that, I'd like to thank you for your attention, and we appreciate looking forward to your feedback.
Thank you, both Steve and Frederick. That was a great demo. I always love seeing the demos. So I'm going to answer the first question. Yes, this webinar is being recorded and feedback information will be sent to everyone who's registered. So even if you have colleagues who have registered but not participated today, they will get a link for the playback information. And that should be sent, that will be sent out tomorrow. There's also a handout for people who want copies of the slides. You should see it under the handout category. And now I'm looking, and right at this exact moment, I don't see any questions, but Frederick or Steve, do you have any additional words of wisdom you'd like to impart on us? Anything we missed, or Frederick, any questions for Steve, or Steve, any questions for Frederick?
So one thing I really liked about the demo is and maybe it wasn't like the main focus on this use case right now, but the possibility of internationalization is one very powerful topic when it comes to different languages or different language models you have to use. It's not just like you could push forward different core models. Probably you would run into big trouble if you do so. And this is something where you will need this semantic relationship to keep the figures in order. Am I right?
Yeah, no. So that's a good question. And in fact, while I was working through the data, I was quite impressed with the way I was using English language. I was using an English language NLP engine to process names in all sorts of languages, and it was doing a pretty good job of keeping up. But if you combine the processing that how you have a named role, you can then be a lot more flexible about how you don't need the NLP engine to tell you what preceded that role was a name, because you know that if it's a noun and it's preceding a known role, that is going to be a name. So yeah, you can absolutely start to use sort of semantics, and as you said before, the context, how that information sits, will help disambiguate and help eliminate false positives. You can actually say with a high level of confidence, yes, I have retrieved a name from here, even if that name is not in the language you're processing the document in, as many of those names weren't.
Okay, I do have another question, and I think this is for you, Steve. How do you disambiguate terms that are used synonymously? For example, a baseball is also a ball.
We are all about context. So there's a couple of things you can do. Sometimes you can actually restrict it by part of speech. So a word might be used as a noun, it might be in a different one context and it's a verb in another context. But because we've actually processed it at the linguistic level, we know when so back, for example, is a noun. It's also a verb. You can look for a particular usage of that word. So rather than, when I used to work with search engines, we didn't have that. All you had was it was BAC. You didn't know where it appeared. Whereas we can actually use the context to help disambiguate. Although in many ways, for example, the classic example is Apple the fruit, Apple the company, Apple the daughter of Gwyneth Paltrow and Chris Martin. But those it may say APPLE, but those words actually have different contexts, and generally in that sort of situation we would have a classification strategy or an extraction strategy that would look for the context before it can actually make a decision as to definitively this is Apple the daughter of Gwyneth Paltrow.
I think the context and the domain itself plays a vital role. As I stated before, when it comes to the more specific but also complex the domain is, the more you have to rely on semantic on some semantic strategy. If you just use plain NER, it won't help.
Okay, and the next question. What is the graph database that underlies Semaphore? Is it an RDF, LPG?
It's RDF. So it's an RDF graph using the SCOSXL kind of structure.
Okay. Okay, what is the difference between a fact entity and an anchor?
A fact entity, you want to return the actual text that's been returned, whereas an anchor, you just want to know it's there. Now, you could have a wildcard fact, a wildcard anchor. It's just, so the definition is the same. It's what you want to do with it afterwards. A fact will get passed down, whereas an anchor is just a point, defines a point in the document.
Okay. So Steve, you showed a quick demo where you moved a judge from current to retired, and in analytics and actually governance, temporality is a really important thing. Can you talk a little bit about how Semaphore manages that?
So in terms of, for the governance aspect, you wouldn't do what I just did, which is literally pick it up and drop it. We have a workflow to make sure that changes to the model that's actually used for downstream processing don't go through without somebody who knows what they're doing having made those changes. So we work in a collaborative environment, so other people can make changes to the model, but it needs to be somebody with experience who can say, I approve that change, make it so. Then we could probably do an entire webinar on temporality and semantics. But basically, what the model is effectively is it right as the model we're using here is snapshot in time. So we're saying this is the current bench. Any document that was tagged at this point in time, that judge will be marked as the current bench. If a document appears afterwards, we tag it as being a past bench. Now, obviously, if you're looking at old documents, you aren't forced to reclassify them. You could just say, oh, I found the judge here. Let's look at the judge. Oh, this judge is now a past bench member. So you don't need to physically go back and retag every document because the knowledge model is browsable. Temporality in terms of you can model for that. So, for example, if a country changes name, you can actually record that in the semantic model, and there's a whole stack of different ways that can be done.
Okay, thank you. Okay, I don't have any additional questions at this time, so I'm gonna give everybody one quick pass. If you have a question, type it in quickly and we'll be sure to address it. And while I'm waiting for people to do that, I want to thank both Frederick and Steve for joining us today, for your time and sharing your expertise. And I still don't have any other questions. So with that, I'm going to give everybody 10 minutes back to their day. So again, thank you everyone for joining us. I hope you enjoyed the webinar, and we'll see you next time.
Thank you very much.
Thanks a lot.